Hi, I'm Andy Brown, and today we're going to be talking about something important to software development, the new product process. I'm also going to be talking about how we as software testers, developers and other software professionals fit into that, and why we should be doing more to influence the decisions in that process. Now, in a previous video, I talked about the Polya process, which I illustrated by adding black rocks and white rocks to a jar, where the probability of adding another black rock to the jar depended upon the ratio of black rocks to white rocks already in that jar. Now, I said that with this process, you could end up with any proportion of black rocks in the jar. But that proportion depended very much upon the colour rocks that were added right at the start of the process. I said that this Polya process was an example of path dependency, where the path you eventually went down was determined by events at the start of the process. Now, in the case of adding rocks to the jar, this was dependent upon random chance events. But there are other times when we are in a path-dependent process. By that I mean that our eventual path is determined very much by the events that occurred right at the start of the process. And sometimes those events can entirely be down to chance, like when we're adding black or white rocks to that jar. But at other times, those events, they may be far from random. And sometimes those events may seem insignificant at the time, but later, when we look back, we realise that they had a huge influence on the eventual path we took. Now, in that previous video with the black and white rocks, I talked about the battle between video recorder formats, the VHS and the Betamax formats. Now, few people today use video recorders. Instead, we use DVDs, or we just stream our content from a provider like Netflix or Amazon Prime. But in the 1980s and the 1990s, the only way to watch films and TV shows at a time of your choosing was within a video recorder. Now, VHS eventually won out over Betamax, not because it was technically a better format, but rather because of other factors. These other factors meant that once VHS had gained a lead over Betamax, then reinforcing loops caused that lead to increase, so that eventually VHS became dominant and Betamax was discontinued. It was like those rocks in a jar. At the start, the number of black rocks and white rocks was equal, but then it diverged. And at the start, Betamax was actually ahead of VHS. Now, one of those reinforcing loops was the network effect. So this is where a network of other product owners or users builds up, and the growth of this network leads to more sales. In the videotape example, people looking to buy a video recorder would likely know friends who also had video recorders, and they may want to share and swap tapes with them. So, if all your friends had VHS recorders, you don't want to buy a Betamax because you can't borrow tapes off any of your friends. Now, another reinforcing loop was complementary goods. So, for video recorders, this was shops like Blockbuster, which rented out the box office films. And again, if you were looking to buy a video recorder, then you'd want to buy one that had lots of films available for rental in your format. If Blockbuster only had one format, say VHS tapes, then you couldn't rent any movies for your very expensive Betamax recorder. And of course, Blockbuster, they would only want to stock tapes in formats that lots of people owned, so they could get a return on their investment. So, you can see the loop for complementary goods becoming a reinforcing loop. Now, this video recorder battle, it was not a foregone conclusion, because Sony, which owns the Betamax format, they became dominant in the professional video recording studios. These reinforcing loops and the structure that drives them is what I'm interested in looking at today. Now, what are the things that are important in becoming dominant in a marketplace, and what influence do we have over them? Now, at this point you might be wondering, why is this important to us in software development? and in software testing. After all, we're in the business of software development quality. We are not in the business of making decisions about marketing. Well, the reason is it's important because we build software and test software so customers can use our software rather than a competitor's software. And it's important that our company or our client is successful. We want to be on the VHS team, not the Betamax team. Even if the Betamax team, arguably, had produced a better product, we still want to be on the VHS team. So this means that one of the things that we need to understand is how markets grow, and in particular how the market for our software is structured, and what are the important levers to pull to influence growth. Now, you may think this is a long way from software testing, which is my specialist area for the past 20 years. You may think this is the domain of marketing or sales, senior management or strategy, and that's true. But it's not exclusively the domain of those functions. We do have an input, and that input is very important, and it must come from us, because nobody else has the knowledge that we have to make that input. Now, testers, developers and other software professionals that are tasked with delivering the quality and functioning of the product that marketing and sales are selling have an important input to that dialogue. And at the moment, that dialogue is occurring mostly without our input, mostly without robust models. So for example, we all know that it's better to fix a bug than not fix it. But we also know that we can't find and fix all the bugs. Or if we do try to do this, we'll release the software so late, it's far too late for anyone to want to use it. So, how do we decide the optimal balance between the need to fix the bugs we find, the need to add more features that the customers want, the need to release software in time to be competitive in the market, and any other demands we face? We decide by making the best guess about how our future will turn out if we choose a given set of options around features delivered, bugs fixed, and a date of release. The things that are within our control. And we marry them up with our expectations about how our customers and competitors will react and how the market will behave. Now, this is attempting to predict the future under conditions of uncertainty, and this is very difficult, and it can lead to lots of frustrations. On the one hand, you, as the quality manager, you may disagree with a given release date, believing that maybe the organisation should release later and fix more bugs in the meantime. Or perhaps the quality manager, product manager and program sponsor discuss where best to focus effort. Is it fixing bugs and reducing technical debt, adding more features that are desired by the customer, or releasing quickly in response to a competitor? Now, at the moment, most organisations make these decisions based upon a gut feel of their experienced managers. And perhaps some organisations, they may attempt at constructing a spreadsheet with numbers to represent units sold, earnings and profit. But it's unlikely that the spreadsheet calculations include realistic modelling for how product quality, numbers of bugs or features will impact sales and profits. And it's even more unlikely that the spreadsheet will include considerations of the various different types of reinforcing loops, the loops that caused VHS to overtake the initial lead enjoyed by Betamax, then eventually dominate the market. But with the tools we have today, we can create models that simulate these effects. We can create a model of new product development. We can include in that model customers and competitors. And we can include loops for the network effect if that's important for our product. So if we're making software testing tool like Selenium, then the more people that use it, the more testers and developers will want to learn that tool. We could also include loops for complementary goods effect, if that's important. So one of the reasons that Apple computers did so badly in the 1990s was that there was very little software actually that you could run on them, certainly compared with Windows. Now, today there's lots of software for Windows and Apple, but much less for operating systems like Linux or Unix or Ubuntu. We can also include loops for other effects if they're important for our particular product. We can then build a model that simulates the market. Now, instead of the quality manager, product manager, and the program sponsor having that discussion about where to focus effort, bugs, features, or release, and that discussion being resolved by using your gut feel, or whoever has the most persuasive argument, the loudest voice, is the most stubborn, has the most influence, or who most closely resembles an angry gorilla, instead of resolving the discussion in that way, you can input values into your model, and you can see how the model responds to those changes. Now, a model will never give you an unequivocal answer that you must always follow. Models are there to help you understand your problem and how the changes you propose are likely to pan out. They are there to help you make more informed decisions. They're not there to make the decisions for you. But now you, the quality manager, the development manager, product manager and program sponsor, and anybody else such as the marketing manager can get together and have a far better informed decision than you ever could before. Instead of those discussions being dominated by make-believe facts, persuasive characters, or dominating personalities, they can be driven by an enlightened exploration, informed discussion, and fact-based reasoning. And we can also be far better at learning. If things don't pan out the way we expected, we have a model, and we can look at it, and then we can try something, pick it apart, and learn what went wrong. Now, in our previous approach, so much time may have passed that we didn't really remember why we made the decision that we did. Now, although we may well remember who in the meeting most closely resembled an angry gorilla. Now, another benefit is that if unexpectedly one of our competitors springs a surprise on the market, we can feed that surprise into our model and better understand what our options are and what our optimum response is likely to be. Now, here's a spreadsheet of a software model built to simulate the effect of two products, like VHS and Betamax, competing to dominate a market. Now, I'm using this book, Business Dynamics by John Sterman. It's a really great book if you want to learn about system dynamics, but I have to warn you, it's not an easy read. But it has a lot of really great stuff for you in there, including the model I've just briefly showed you. Now, this is a simple growth model, and it only includes the network effect, not other things like the effect of the complementary goods market. Nor does it include things that we're interested in, like the effect of high or low quality, the effect of releasing just a minimal viable product, or releasing a fully feature-rich product. But once we've built our model and understand it, then we can extend it in different ways and answer the questions that we or our clients are interested in answering. Now, in the next session, I'll explore this model, including showing you how I built it. Plus, I'll run through a few more simple scenarios so you can understand how you might use it or models like it to help you and your team make better decisions. Like whether it's better to release now with this level of features and bugs or to delay release. If you've enjoyed this session, please give us a thumbs up on the YouTube channel. And if you're interested in this topic, please hit the subscribe button on the YouTube channel. Thanks for watching, and I hope to see you again.